Alrighty, let's go about solving some compound inequalities. We've got Algebra, Chapter 2, Section 5, Monitoring Progress, numbers 3 to 6. Solving compound inequalities. Let's take a look. Alright, so when you've got a compound inequality that's an AND statement, we can solve both parts of it at the same time. So we're going to start here. We want to get the term that has the variable by itself, so we're going to subtract 4. And then we'll also subtract 4 from this part of the inequality and subtract 4 from over here. So we're kind of like solving two inequalities at the same time, which is really pretty nice. Alright, so let's see here. We'll have 5 minus 4 is 1, less than or equal to m, less than 6. And we're done. Let's go ahead and graph it. Alright, so 1 is, let's see, we've got a down here by 1, and here we've got 6, so m is going to be between, it's going to be bigger than 1 and less than 6. So it can't be over here because this would be bigger than 1 but not less than 6, and it can't be down here because that would be less than 6, true but not bigger than 1. It has to make both these things true. Also notice this is a or equal to, so we're going to fill in the bubble at the 1. Alright, next. So again, we've got another inequality like this where it's an AND statement. So first we're going to isolate the term that has the variable in it by adding 5 to both sides. And of course, when we say both sides, we're solving two inequalities at the same time. So we're going to do them all together. Negative 3 plus 5 works out to positive 2. And we've got the 2k's now by itself, and 7 plus 5 is 12. Next, we want to get the k by itself. We want to isolate the k by dividing by 2. So we're going to divide by 2 on both sides. When we say both sides of the inequality over here and both sides of the inequality over here. You're solving two inequalities at the same time. So 2 divided by 2 is 1, less than k, less than 6. So k is going to be bigger than 1 and less than 6. That. Alright, so here's 1 and here's 6, and k is going to be between them because it's going to be bigger than 1 and also less than 6. So again, not over here and not over here, only in the middle. And these are both greater than with no or equal to, so we leave the bubbles open. Alright, let's take a look at the next one. Now we've got our first OR inequality. Hi, Sammy. So here we got to solve the two inequalities separately. So we want to isolate the term with the variable by subtracting 3 on both sides. Let's see. So we get 4c is less than or equal to negative 8. And then we want to isolate the c by dividing by 4 on both sides. And that's going to leave us with c less than or equal to negative 2. And then over here with this second inequality, when it's an OR inequality, we're going to have to do them separately. So let's see. First, we're going to add 8 in order to isolate the c on both sides, of course. And we end up with c greater than, let's see, negative 1 plus 8 is a positive 7. All right, so let's go take a look at graphing this. So c is going to have to be less than negative 2. So there's the negative 2. And c could be on down here. It's an or equal to, so we're going to fill in the hole there. Or c could be bigger than 7. So it could either be down here or up here on the other end. All right, next. All right, so again, it's an OR statement. So we're going to have to solve the two inequalities separately. We want to isolate the term that has the variable in it by subtracting 1 on both sides. That's going to leave us with 2p less than negative 8. And then we want to isolate the variable itself by dividing by the coefficient. That's the 2. And that's going to leave us with p less than negative 4. Or, on the other hand, the second inequality, in order to isolate the term that has the p. We're going to subtract 3 on both sides. That's going to leave us with negative 2p less than or equal to negative 4. Notice that the negative up here sticks with the 2p. Next, we're going to have to divide by the coefficient in order to isolate the variable all by itself. So we're going to divide by negative 2 on both sides. Notice that on this side we just get a p, and because we divided by a negative, we're going to have to reverse the inequality. And negative 4 divided by negative 2 is a positive 2. All right, so let's go take a look at graphing that. First of all, p could be less than negative 4. So here's our negative 4. P could be anything less than that. It's not an or equal to, so we're going to leave it open. And then also, p is greater than or equal to 2. So it could be 2. We'll fill it in because it's an or equal to, or anything bigger than 2. Notice on this one, if you had forgotten to switch the inequality in that last step, then you would have been trying to graph an arrow that went this way. And if you get something like this, when you're doing a compound inequality that's an or statement, you should be a little bit suspicious. Something might have gone wrong there. Alrighty, and we're done.